These are the contents of this video session. This is the overall idea of how to analyze a use case. So as the picture says, the particular analyzing a use case is done by a use case engineer, for which we have four different inputs. First one is called as a use case model. Second is some supplementary requirements. So the major requirements will be gathered in the form of a use case model. Apart from this, we have supplementary requirements, business model, and then architecture description. So based on these four inputs, the use case will be analyzed, and then finally the output of this particular analyzing will be your analysis classes, and then followed by use case realization. What are these analysis classes? Classes that are identified during analysis phase, that is the first phase of project development, is called as analysis classes. Mainly, these classes will represent a crisp abstraction of the problem domain. And also they should map to the real world business concept. So a class, the analyze class should not be very vague or very generic. It should be a very crisp abstraction of the problem domain. So this analysis classes should represent a very high level set of attributes. So don't go for analysis class with one or two attributes, etc. So it should have some high level of set of attributes. And analysis class operations should also specify the key services that the class should offer for the benefit of the entire project. So this is the anatomy of an analysis class. So it is represented by using a rectangle icon with the three compartments in it. So the first compartment holds a class name, second says a set of attributes, and third says a set of operations. So apart from this particular thing, the name of the class is very mandatory. Optionally, we can have attributes and also operations, but at least the name should be mandatory whenever you represent analysis class in a diagrammatic way. Apart from this, we have visibility, stereotypes, and tagged values. So the meaning of all these we have discussed in the previous video session. What makes a very good analysis class? So the idea here is that whenever you are identifying any class and making it as an analysis class is not that much easy activity. Its name should reflect its intent. So naming a class, it should be very good in such a way that its purpose should be reflected by its name. And it should be a crisp abstraction, as we have already discussed. It maps to a clearly identifiable feature of the problem domain. So it should be related to one particular solution for a problem domain. It has a small, well-defined set of responsibilities. It should have a very good high cohesion. So cohesion means it is a bonding within a class. So a class should be dependent on itself for any functionality. At the same time, it should have low coupling. Coupling means it is a bonding between two classes. So a class should not be too much dependent on other class for solving any functionality. So these 2 points are very important to be in mind. So it should have high cohesion, but the coupling factor should be very low. There are certain rules of thumb which you need to keep in mind whenever you identify classes from the problem statement. So the first one is called as the classes must be much simple. So don't go for too much vague class or too much generic class. So having about 3 to 5 responsibility per class is optimal. So no class stands alone. So the thing is that any class should have at least 1 or 2 collaboration with other classes. Unique class without isolated class without any communication with other classes is not advisable. Beware of many very small classes. So don't have a lot of small classes with 1 or 2 responsibilities. As we have already discussed, 3 to 5 responsibilities is apt for any particular class. So in such case, if you have 1 or 2 responsibilities, 1 or 2 many classes, you can merge them to form a single class. Similarly, beware of few but very large classes. So don't have classes with greater than 5 responsibilities. In such case, reduce them into smaller classes. Next main rule of thumb is that beware of functoids. Functoids is a normal procedure function which is treated as a class. That is, it is a class with only one function. So if a class which is having only one function is termed to be a functoid class, so that class should be avoided. Beware of omnipotent classes. So omnipotent classes are those which seems to do everything. So it is said to be more generic class, a class which is going to solve all the responsibilities of the entire problem domain. That is again not advisable. So in such cases, divide into many cohesive classes. Avoid very deep inheritance trees. So you use inheritance only when there is a clear and obvious inheritance hierarchy arising directly from the problem domain. Don't go for very deep inheritance trees, which is going to include multiple classes and responsibilities. So these are some of the rules of thumb which you need to keep in mind whenever you are designing any classes. The next part of this video session focuses on a very important question: how to find class from the problem statement. So there are three different methods to find classes. First one is to find classes using noun and verb analysis. Second is used to find class using CRC analysis. And third is to look from other different sources of classes. So finding classes using noun and verb analysis, this is the first method. So for this, what we do is that we take the requirements in our hand, which is called a software requirement specification, and also we can take supplementary requirements as well. And then we are going to identify the noun and noun phrases which is present in the particular requirement. So such noun and noun phrases will be treated as classes or its attributes of the classes. Similarly, we are next going to find the verbs and verb phrases. So such verbs and verb phrases will be converted as responsibilities of that particular class. So for this, we need a clear understanding of the problem domain. It's very important. So some stepwise procedure for identifying noun and verb phrase analysis. So what we do is that first step is that we are in need to collect much relevant information from many sources. As I have already said you, the first major source will be use case diagram and use case specification, and also your requirement specification. Apart from this, we go for supplementary, that is add-on requirement specification. So if it is existing, we can take it, otherwise we can drop it. Apart from it, use case and also the project glossary. It is again important. And some other information such as architecture, vision documents of the company, etc. So take all these sources, analyze these sources. Now in step 2, we are in need to highlight the following. So all these sources will be in the form of English grammar. It will be in a natural language. So from that, what we are going to do is that we are going to highlight the nouns and noun phrases. An example for noun is like flight, customer, etc. Our noun phrases like flight number, customer identification, etc. So these two ideas, these two noun and noun phrases will be classified as classes or attributes. Similarly, again you highlight verbs like allocate, compute, salary, like which. Similarly, verb phrases also will be taken into account. Verify, credit card, pay balance, etc. So like these are some of the verb phrases. So now these two will be converted as responsibilities. So these are the two different steps of the analysis procedure. In third step, what we are going to do is that we'll be after listing the candidate classes, attributes and responsibilities, we'll be tentatively allocating these responsibilities, that is and attributes, together into a class. And after which we can group the listed attributes and responsibilities, and then we can reallocate the classes later onwards. So this is the idea of noun and verb analysis procedure. Next type is to find classes using CRC analysis. So the expansion of CRC is class, responsibilities and collaborators. As we have already discussed in the first unit, CRC is a card actually, which is in a rectangle shape, which has 3 different compartments. So this particular card will be populated by brainstorming activity. Brainstorming means a person will be saying his or her view, and all others will be arguing with the particular view, and then a final conclusion will be met. So this CRC card will have 3 different compartments in it. So here the top compartment is going to record the class name. And the left compartment, we have responsibilities. Responsibilities mean the major functions which is present in this particular class. And in the right compartment, we used to specify the collaborators of this particular class. So collaborators are the class which are in association or which have some relationship with some other class. So here we go for CRC analysis procedure. So input for this particular thing will be use cases, requirements, glossary and other relevant information. So CRC is actually a 2-phase activity. In phase 1, we will be brainstorming and gathering the information, and in phase 2, we'll be going for analyzing the information. So first we'll be starting with phase 1. So in phase 1, the participants of this particular phase 1 will be object-oriented analyst, stakeholders and domain expert. So stakeholders will be customers, project manager and project developer, etc. And then in brainstorming procedure, the first step is that we are in need to explain the overall content of the project. as a form of true brainstorm. True brainstorm means here all ideas are accepted as good ideas. If any person is saying an idea, don't debate or don't go for any argument. Just record all the ideas which is given by all the persons, participants of this particular brainstorming activity. And in second step, we will be asking the team members to name the things that operate in a business domain. So any physical entities which are all present in this particular problem domain will be listed, and they will be, and those things will be named. For example, customer, product, servers, ATM card, mission, etc. So write each thing in a sticky note, and we will be just stick the particular note in a wall or a whiteboard, so that everybody later onwards they can see to it, and they can this can be used for analysis process also. The third step is that again we'll be asking the team to share the responsibility of those things. So initially we have identified the things, we have named the things. Now the responsibilities of the things will be identified. Record this in the second compartment. And finally again we will be identifying the classes that might work together. So to identify the collaborators, and record them in the third compartment. So based on these 4 steps, the brainstorming procedure is completed. In the second phase, we'll be analyzing those information. So the participants for these will be OO analyst and then domain expert. So the input for this particular phase will be the output of the previous phase, that is your brainstorming. So all the classes in the form of sticky notes, their responsibilities and collaborators will be the input for this analyzing phase. And the procedure here is that we'll be applying the rules of thumb. So last few slides back we have discussed 7 rules of thumb and other standard requirement of classes. So those rules will be applied and the classes will be filtered. So we can add, remove, even we can divide, or we can consolidate, that is grouping together the classes to form final list of classes, responsibilities and collaborators. So after the second phase is completed, our CRC approach is completed, and final list of very good classes with responsibilities and collaborators will be consolidated. The third approach is looking for other sources of classes. So we can, apart from the requirement specification, apart from use case specification, use case model, etc., there are some other sources from which also we can identify the classes required for the problem statement. So such other sources are physical objects. So any physical object which is not present in the particular software requirement specification, like aircraft, people who involve, hotels, organization, etc., any physical entity can be also grouped as classes. Paperwork is another rich source of classes. For example, if any bill will be paid, that is invoice, orders, pay slip, report card. So for the corresponding project, we may have some extra paperwork. So using that paperwork also, we can identify the classes present in it. Next are the known interfaces to the outside world. So for my project, if any user interface screen is available, touch screen is there, then that particular screen can also be acted as a class. Keyboards, peripherals and other systems. And finally, conceptual entities. If we are in need of any database, any cloud storage, if there is any payment gateway, these entities are not physically existing, but they are conceptually related to our project. So such type of conceptual entity can also be treated as classes. First cut analysis model. So the idea of this model is to consolidate the input which is obtained from 3 steps, that is noun and verb analysis, CRC and other sources. So we will be consolidating all these 3 things together to form a single UML model. So the steps for this will be compare all 3 sources of information. And finally, we will be consolidating the final analysis class which occurs in all the 3 approaches. Similarly, it attributes and its responsibilities. Now, we will be resolving synonyms and homonyms. So, if 2 classes is going to give the same meaning, then we can treat it as a single class. Similarly, homonyms will be 2 different words but with a different meaning. So, in such cases, we are in need to either rename the class or we can do some generic classes. So, that can also be done. That is, resolving those issues by using project glossary will be done, so that the identical classes and the duplicate classes will be removed over here. Look for the differences in the results and of the 3 different techniques and resolve the differences. Next, we will be refining the collaborators that represents the relationship between the classes. So all the collaborators which we have identified in the previous 3 different approaches will be refined and final consolidation will be done. Then finally, we will try to improve the naming of the classes, attributes, responsibilities, and we will be following the standard naming conventions. So the output of this particular activity will be the set of analysis classes, where each class may have some key attributes, should have at least 3 to 5 responsibilities. That's all about today's video session. The contents are referred from the book cited here. Thank you for your patient listening.